All right, so let's take a look at the last one here. So again, the directions say, simplify by rewriting the expression over a common denominator. So I've got two fractions, and I'm going to get a common denominator, which probably means I'm going to then add these two fractions together. That'd be why you would get a common denominator. So this denominator has a cosecant and a cotangent. This one just has a cosecant, so it's missing a cotangent. So I need to multiply this fraction by cotangent over cotangent. Okay, so I need to multiply the denominator by cotangent, and as long as I do the same thing to the numerator, then I'm allowed to do that. So let's see what happens. So this would now be cotangent squared. Cotangent squared. This is now cotangent cosecant. And then this is 1 over cosecant cotangent. Now the order of those doesn't matter. I've got two things multiplied together, so these are the same thing. So that means I can add them together. All right. So if I add them together, I'm going to add the numerators, cotangent squared plus 1. And then they're going to both be, this is going to be over this common denominator. So cosecant cotangent. All right. Well, we did what they told us to do. Now, by doing that, I have this cotangent squared plus 1. Again, whenever you see something squared, like plus or minus 1, go to your Pythagorean identities and see if you can find it. Cotangent squared plus 1 is cosecant squared. Okay, so let's replace that with cosecant squared. But I have a cosecant on the bottom that's going to cancel one of those. So now this is going to cancel. This is not going to be squared anymore. And I'm going to have a cosecant over a cotangent. Now, I could stop there. Again, when we get to the identities, you're going to know where to stop because the one side of the equation is going to tell you, where you're trying to get to. Or I could keep going with this, like cosecant. Cosecant is the reciprocal of sine. So this is 1 over sine. Cotangent is cosine over sine. So these two sines are going to cancel, and you're going to get 1 over cosine. But what is 1 over cosine? It's secant. I think that's a good place to stop, because it's just one thing. Okay, so this expression turned into, after a bunch of work and a bunch of simplifying, this expression. Okay, so now we're going to take a look at what are called identities. So take a look at the back of your notes. And you're going to see this. Okay, so establish an identity. So we are going to be given, so now we have an equation. We don't have an expression. This side is an expression. This side is just, well, that one's just a trig identity. Or that's just a trig function. So we are going to see if we can manipulate this and turn this side into this side. When you do these, you always want to start with like the more complicated looking side and see if you can simplify it into the other side. Okay, so let's take a look and see what happens. So what do I have? I have sine times the cotangent plus the tangent. One thing that is sometimes helpful is to rewrite everything in terms of like sine and cosine. So you're using like the same variables, and you can see what's going to cancel or what's going to be squared and things like that. So I'm going to leave the sine for a second. I'm going to rewrite cotangent. Cotangent, so tangent is sine over cosine. So cotangent is cosine over sine. So cosine over sine. And then this is sine over cosine. Sine over cosine. Okay? All right, so that's all I've done. I'm not doing anything to this side. I'm going to leave it, and I'm going to see if I can slowly but surely turn this side into that side. All right, what should I do now? Well, I've got something multiplying some parentheses, so let's go ahead and distribute and see what happens. So I'm going to take sine times this first fraction, which means these two signs are going to cancel, and I'm just going to have a cosine. I'm going to take sine times this fraction, which that's going to give me sine squared over cosine, and that's all I have now. Now, I have, what do I have? I have two things that are being added together, but they don't have like common denominators. I have a fraction and I have an expression right here. So let's think of that as a fraction for a second. And then let's simplify this. I have two things that are being added together, and over here I just have one thing. So let's simplify. Let's see if we can kind of cram this together to turn it into one thing. So I would need a common denominator, which means I need a cosine here. But if I multiply this bottom by cosine, I'm sorry if my pen's sloppy. I was trying to make sure you could see things, but it's kind of bleeding a little bit. Then I would have to multiply the top by cosine. Okay, so you gotta be fair. Now that's going to give me a cosine squared right here. So this will be cosine squared over cosine, sine squared over cosine, which means now I can add these together and get cosine squared plus sine squared over cosine. But wait a minute. Cosine squared plus sine squared is, so don't be afraid to turn the page, that's 1. That's the Pythagorean identity. So I can literally rewrite this numerator as 1 over cosine. Lo and behold, 1 over cosine is secant. And so I have proven this identity. I've manipulated this side and shown that it is equal to that side. Okay? Now, I did a lot of things there, and you are not going to look at that and go, oh, this is easy. It makes sense. Okay. A lot of times you just need to try something. Okay? There's going to be, every one of these, there's going to be something different about it. And maybe a different trick I use that kind of turn an expression into something that looks, that I can use. Okay, so don't be afraid to just try something. Okay, don't use a pen like I am, because if you start working the problem and it's not working, then just erase it, go back and maybe try something else. Okay, so there's different ways to do these. Okay, you and a friend could be working together, working independently, and you come together and find that you solve these completely different ways, but they both work. Okay, so what I'm going to be looking at on a test is your work. Does each step make sense legitimately, and are you slowly turning into that other side over there? Okay? Once you make a mistake, if you just kind of make something up that isn't really a rule and just keep going, there's not a whole lot I can do as far as partial credit. Okay? So a question like that may be worth 3 or 4 points. And depending on kind of how far you get before you make a mistake is going to be determine kind of like how many like partial credit points I can give you. Okay, so let's look at B. Okay, now this one I could turn this side into this side, I could turn this side into this side. There's no rule. Okay, either way works. I'm going to show you that I can turn the right into the left. Okay, now I'm also going to use a little trick we learned on the front page. My denominator here is 1 plus cosine. It's got a 1. It's got a trig function. It's not squared. It's also got a plus. I really want a minus. What I'm going to do is I'm going to take this 1 plus cosine and I'm going to multiply it by 1 minus cosine. If you take an expression like 1 plus cosine or 1 minus cosine and multiply it by its conjugate, it will magically turn in to 1. Your middle terms will cancel, and you'll get minus cosine squared, which is one of your Pythagorean identities. Okay, so that's probably going to help us. Now, if I multiply the bottom by that, I also have to multiply the top by 1 minus cosine. Now, I am not going to distribute this. I'm going to leave it out for a second. Maybe I want to multiply it in. we did something like this on the front page, and after I multiplied it in, we found that I had to factor it back out. So let's just leave it out for a second. Now, 1 minus cosine squared is a Pythagorean identity. It's equal to sine squared. So maybe you're going to see why I left that sign out. So, sine, and then 1 minus cosine squared over sine squared. Now, that sign is going to cancel one of those, so there's still a sign down there. So we have 1 minus cosine squared over sine. Now, the rule is you have to completely turn one side into the other side. You can't work this way, this one down a bit, work this one down a bit, and then try to make them meet. You have to leave one side completely alone. That doesn't mean we can't think about what this is. So like cosecant. Cosecant is 1 over sine. Cotangent is cosine over sine. Well, look at what I have here. I have a 1 that's being divided by a sine. I have a cosine that's being divided by a sine. And so if I think of this division using the distributive property, I would have 1 over sine minus, I'd have cosine over sine, and lo and behold, 1 over sine is cosecant, cosine over sine is cotangent, and again, I have just proven that this side is equal to that side, and that's an identity, and that's all we're doing. All right, let's look at the next one here. Whew, this one looks ugly. There's a lot going on here. I've got a sine over a cosecant. I've got a cosine over a secant. I've got this expression over here. Now again, it's always best to try to simplify the more difficult looking side and turn it into the easier looking side. I'm going to say this is more difficult. I've got all this going on. I got these two fractions. I also have 4 different trig functions. Sine, cosine, secant, cosecant. I do not like that at all. So the first thing I'm going to do is I'm going to turn cosecant and secant into expressions that involve sine and cosine. That way I'm only going to have 2 different trig functions, and maybe I'm going to see how they relate to each other instead of these 4 different trig functions. All right, so sine over, and then what is cosecant? Cosecant is 1 over sine. Okay. Plus cosine. Secant is 1 over cosine. But if sine is being divided by 1 over sine, dividing by 1 over sine would be the same as multiplying by sine over 1. It's reciprocal. So you're literally taking sine and multiplying it by sine. So that's going to be sine squared. Same thing's going to happen here. The cosine is actually getting multiplied by cosine. So that's cosine squared. Oh, sine squared plus cosine squared is one of our Pythagorean identities. It's equal to 1. So what? Uh-oh. Everything just disappeared on me. I was supposed to end up with this over here, and somehow everything just canceled. All right. Look at the front page. Notice, here's the problem. We were trying to turn this into cosecant squared minus cotangent squared. I have something squared minus another something squared. Does that just so happen to be one of my identities? Cosecant squared minus cotangent squared is equal to 1, which means I can replace the number 1 with this expression, which is exactly what I wanted to do. All right, so yes, I have turned this side into that side, and I have proven that identity.